Hi Chem 30s, topic 3 today, predicting redox reactions. Hi Chem 30s, today we're looking at topic 3, predicting reactions in solutions. You guys have all of these notes for you in your workbook, so open up and find the page, and you guys can follow along with what I'm saying, and then you can pause the videos as you need to when we are doing the examples. So what we're looking at today is the 5-step method, where we can figure out if something is going to undergo a reaction, a spontaneous reaction, or if it's not going to undergo a reaction and be a non-spontaneous reaction. So just a reminder, Svante Arrhenius told us that in solutions, molecules and ions behave approximately independently of each other. So when we're looking at all of our entities that are reacting, it's a good idea for you guys to think about this table here. Now it is in your textbook, but of course I've also provided it for you guys. So when we're thinking about a solution, you're thinking about solids, liquids, gases, aqueous breaking up into its ions, acidic solutions, and basic solutions. So if something is telling you it's happening in a solution, for sure one of your entities that you are going to list is water, H2O liquid. If you are told that a solution has been acidified or that it is in acidic conditions, another one of your entities you're going to list is hydrogen ions. Likewise, if it's in a basic solution, you're going to list that you have hydroxide ions as an entity. Some oxidizing and reducing agents are combinations. So if you look on your table, you'll see your oxidizing agent MnO4 acts as an oxidizing agent when it is with hydrogen ions, and only when it is with hydrogen ions. You guys will see an example of this right off the bat. Also, at the end of today's lesson, we're going to look at disproportionation, and that means when you have an oxidizing agent and a reducing agent, which is the same thing. So a couple of things can act as both oxidizing agents and reducing agents. So you will find water on the left side of your table as an oxidizing agent, but also H2O on the right side of your table as a reducing agent. Same with iron. You'll find Fe2 positive on the left side, producing Fe solid. You'll also find Fe2 positive on the right side of your equation, producing Fe3 positive on the left side of the equation. So Fe2 positive can act as oxidizing and reducing. Same with your copper 1 ion, your tin 2 ion, and your chromium 2 ion. So we're just going to go through the steps for writing a redox reaction. So the first thing we're going to do is we're going to list all possible entities that could be present within the solution. Use this table here for hints, and also remember you're thinking about your cations and your anions. Remember, weak acids do not ionize, so they are not going to break up into H positive and then whatever the anion is. It is only strong acids that we're going to ionize, and we'll practice this more in the next lesson. We're going to label all of our entities as either oxidizing agents or reducing agents, and we're going to do that by looking at our table on page 7. If we see that our entity shows up on the left side, it's an oxidizing agent. If we see that it shows up on the right side, it's a reducing agent. So we're going to do this example here. I'm just going to go through the next steps first before we move into this example. So step 2, after we've written all of our entities, chosen which are oxidizing and which are reducing agents, we're going to use our data table to pick our strongest oxidizing, our SOA, and our strongest reducing, our SRA. Then step 3, we're going to write the half reactions for the strongest oxidizing agent shown on your redox table. We're going to look at that reaction moving from left to right, and that's how we're going to write it. Then we're going to write our half reaction for the strongest reducing agent, reversing the reaction. So we're going to look at our reducing agent on this side, on our right-hand side, and writing our equation from right to left for our reducing agent. Then we're going to add the two half reactions together. Make sure before we add them together that our electrons balance. And then finally, we're going to determine if the reaction is spontaneous or non-spontaneous by looking to see if the oxidizing agent is above the reducing agent. Then it is a spontaneous reaction. If our oxidizing agent is below our reducing agent, then it is a non-spontaneous reaction. So let's go ahead and look at the examples that I have for you guys today. Okay, Chem 30s, let's work through this first example together. For this one, we've got copper metal, which is placed in an acidic solution of potassium permanganate. So our first step tells us to write all of our entities out. So it tells us we have copper solid, not the copper ion. It's really important that you distinguish if you've got solids, gases, liquids, ions, things like that. So we have copper solid. And we know that it's placed in an acidic solution of potassium permanganate. So we have K positive, we have permanganate, MnO4 negative. It's an acidified solution, so we have hydrogen ions. And of course, because we're in solution, we also have H2O. Now we're going to use our redox table on page 7 and figure out which one of these entities are oxidizing agents and which are reducing agents. Okay, so let's have a look at the table. Now you can see here our MnO4 with our hydrogen. That is an oxidizing agent. Then down here we have water on the left-hand side. So water acts as an oxidizing agent. And then our potassium ion also acts as an oxidizing agent. On our reducing agents, we can look. Copper solid acts as a reducing agent. And then H2O also acts as a reducing agent on our reducing agent side as well. So we can see that water is acting as both a reducing agent and as an oxidizing agent. It matters which side of the arrow you find your entity on, whether you can label it as an oxidizing agent or as a reducing agent. So now that we've looked on our data table, let's go ahead and list our entities as oxidizing agents or reducing agents. So copper we decided was a reducing agent. Our potassium ion is an oxidizing agent. Our permanganate ion acts as an oxidizing agent, but only with our hydrogen ion. So we put those two together by joining them with a line. And our water acts as an oxidizing agent and as a reducing agent. We find it both on the left side and the right side of the arrows. Now we're going to go back and look at page 7 again, and we're going to pick which is our strongest oxidizing agent and which is our strongest reducing agent. So remember when we're doing that, our strongest oxidizing agent is going to be the one that we find on the topmost left-hand side. So this is our strongest oxidizing agent here, our MnO4 with our hydrogen ions. And our strongest reducing agent, of course, is the one that shows up the closest to the bottom right-hand side. So as we go up on the right-hand side, our strongest reducing agent is the copper, because that is the one that shows up lowest down on the right-hand side. Right, strongest reducing agents goes from bottom right, and then the weakest is the top right. Strongest oxidizing is top left, weakest oxidizing is bottom left. All right, so our strongest oxidizing agent we have chosen is our MnO4 and our hydrogen ions. So this is our strongest oxidizing agent. And then our strongest reducing agent is our copper. The next step then is to write the half reactions as we see them on our table. So if you look at your strongest reducing or your strongest oxidizing agent, we have MnO4 negative plus 8 hydrogen ions and 5 electrons. Right, this is our oxidizing agent. It's being reduced, electrons are being added. It produces Mn2 positive and 4H2O. All right, now we're going to look at our copper one. When we're reading our copper one, because it's our strongest reducing agent, we do have to write the equation from right to left. So here we're going to write copper solid, and we're reading from right to left, copper solid, and then copper ions, and 2 electrons. So there we have our 2 half reactions for our strongest oxidizing agent written left to right on the table, and our strongest reducing agent written right to left. The next step is to balance the electrons and then add them together. So here we can see we've got 2 electrons for copper and 5 electrons for our permanganate ion. So what we're going to have to do to make our electrons match, we want 10 electrons. We're going to multiply this by 2, and we're going to multiply our copper one by 5. Now I talked to you guys about this already. You can see that these equations are getting a lot longer. So it is a good idea before you add them together to actually add all this together, and then so do the multiplication for each of them and then do the addition. So I'm going to say that I've got 2 MnO4 negative plus 16 H positive plus 10 electrons produces 2 Mn2 positive and 8 H2O. Then I'm going to go down to my copper, and I'm going to say I've got 5 copper solid, which produces 5 copper ions, plus my 10 electrons. Now I can go ahead and add these together to get my net reaction. So I have 2 MnO4 negative plus 16H positive. My 10 electrons on my left-hand side cancel out my 10 electrons on my right-hand side. So I have electrons as both reactants and products. They are the same number. That's how I know that I can balance these two together, and I'm going to cancel out my electrons because they're the same on each side. My last reactant is my 5 copper. It produces 2 Mn2 positive plus 8 H2O plus 5 copper ions. Excuse me, snow leopard. All right, I do want to fill in my states to make sure that this is complete. So this is aqueous, solid, aqueous, liquid, and aqueous. And the last thing I want to do is I want to predict my spontaneity. So is this going to be a spontaneous reaction or not? Remember, the way that you test that is if your oxidizing agent is above your reducing agent on your redox table. So OOT, oxidizing agent on top. My oxidizing agent, remember, is my MnO4 and my H positive, and my reducing agent is my copper. My oxidizing agent is above my reducing agent. So that means that this is a spontaneous reaction. So I can finish off this equation just by writing an SP for spontaneous on the top. All right, let's go ahead and try our next example. Okay guys, I want you to try this one first by yourselves. So you can pause the video right now if you haven't done it already. And then check with me in a couple of minutes, see if you guys got the right answer. So remember to follow all those steps, picking your strongest oxidizing, your strongest reducing, writing your half reactions left to right, right to left, balancing your electrons, writing your net reaction, and predicting spontaneity. So go ahead and do that, and then check back with me in a couple of minutes. Alright, so for this one we have a lead strip which is placed in a copper 2 sulfate solution. So let's go ahead and write out the entities that we have. We have a lead strip, so that means that that is going to be Pb solid. It's placed in a solution of copper 2 sulfate. So our copper 2 sulfate is going to break up into its ions, our copper 2 ion and our sulfate ion. And then we also have H2O. Right, this reaction tells us nothing about being in acidic or in basic solutions. So we're just writing our entities as we see them. No hydrogen ion in this one. We don't have an acidified solution. Now we're going to check our table again. Now remember, when we're checking our table, we're only checking for these entities. So oftentimes students would say, oh, well, I've got the lead ion, but you don't have the lead ion here. Make sure you're reading your question. You only have lead solid. So you can only pick lead solid as one of your entities, and it's a reducing agent, right? You have the copper ion. Your copper ion is an oxidizing agent. You don't have copper solid, so you cannot choose copper solid as a reducing agent. Your entities have to be showing up on your table on the proper side, the left hand or the right hand side. Don't be making up ions or making up solids that you don't have. Also, be looking for any entities that do go together, right? So be checking if you have two things that are working together as oxidizing agents or reducing agents. Always check that. If you have water, remember, water is always going to be an entity in a solution. It is both an oxidizing agent and a reducing agent, so watch out for that. So let's go ahead and look at page 7. I've already mapped it out for us. So we found our copper ion as our strongest oxidizing agent. Here we also have water acting as an an oxidizing agent, and SO4 2 negative and H2O are acting as oxidizing agents. So we've chosen all of our oxidizing agents. However, our copper is the one that comes first. It is our strongest oxidizing agent. Now we're going to look over here for reducing agents. We've got lead solid and sulfate. Okay, this is a reducing agent. Lead by itself is also a reducing agent, and then water is a reducing agent. Because lead and sulfate show up the lowest on the right-hand side, that's where our strongest reducing agents are. Our lead and our sulfate are our strongest reducing agents. So we can go ahead and write our half reactions for our strongest oxidizing and our strongest reducing agents. So let me just catch up with us here. We said that lead was a reducing agent, and lead and sulfate was a reducing agent, and water was a reducing agent. Okay, copper ion is an oxidizing agent, and then water is an oxidizing agent. And then also we found out that that our sulfate and our water working together were also oxidizing agents. When we looked, our strongest oxidizing agent was our copper ion, and our strongest reducing agent was our lead and our sulfate reacting together. So let's go ahead and write our oxidizing agent reaction. So we're going to write from left to right. Copper ions plus 2 electrons produce copper solid. And now we're going to write our lead and our sulfate from right to left. So when we look over here, we've got lead solid plus sulfate. Our sulfate ion. And that produces lead sulfate and 2 electrons. All right. Our 2 electrons are already matching, so we don't need to balance our electrons. We can just go ahead and write our reaction, our net reaction. So here we have copper ions plus lead solid plus our sulfate ions. Right, our electrons cancel out. This produces copper solid and lead sulfate solid. Next, we're going to predict our spontaneity. We can see that our oxidizing agent, the copper ion, is above our reducing agent, the lead and sulfate. So again, this is another spontaneous reaction. Disproportionation is a reaction where a species connect both as the oxidizing agent and as the reducing agent. If you guys look on your periodic tables, you'll see there are many species which are both oxidizing agents and reducing agents. And we talked about some of them at the beginning of the lesson. So water can act as an oxidizing or a reducing agent, iron, chromium, there's lots of examples up there. So let's go ahead and have a look at when the iron ion behaves as both an oxidizing and a reducing agent in solution. So the last example we have is our disproportionation reaction. We are talking about iron, 2 ions in solution. So we're just wondering what happens when 2 iron 2 ions collide. So the only thing that is present in our solution is the iron 2 ions and our H2O. So let's look over at our chart on page 7. And you guys can see here for our oxidizing agents, we've got the iron 2 ion on the left side acting as an oxidizing agent, and of course water also acting as an oxidizing agent. If we follow the right hand side up, we also have iron 2 ions up here. They become iron 3 ions when they're acting as reducing agents, and then water above it. So our strongest oxidizing agent is our iron 2 ion, writing it from left to right, and our strongest reducing agent is our iron 2 ion, writing this equation from right to left. All right, so let's go ahead and do that. So our iron 2 is acting both as a reducing agent and an oxidizing agent, and so is our water. but our iron 2 is the strongest oxidizing agent and the strongest reducing agent. So when iron is an oxidizing agent, we have Fe2 positive plus 2 electrons producing Fe solid. Right, we're reading this equation from left to right. Now we're going to look at the reducing agent equation. Here we have Fe2 positive reacting to form Fe3 positive and an electron. So we need to balance these out. We've got 2 electrons here and 1 here. So we're going to multiply this by 2. So our net reaction is going to be 3 Fe2 positive. Our electrons now will cancel out, and we have Fe solid and 2 Fe3 positive. Okay. When we have a look at this reaction to predict spontaneity, we can see our oxidizing agent is below our reducing agent. Iron 2 positive as an oxidizing agent is below iron 2 positive as a reducing agent. So this reaction is a non-spontaneous reaction. So what happens when iron 2 reacts in water? Nothing. It's a non-spontaneous reaction. So there's an example of disproportionate. Our last example for today is just asking you if a solution of chromium 2 chloride would be stable, meaning would it be reactive or not? Could you have a solution of chromium 2 chloride? Would it sit there and do nothing, or would it react? So let's go ahead, write out our entities. So chromium 2 ions, chloride ions, and then of course H2O, because we're in solution. So looking here, we're going to figure out on page 7 again what are our oxidizing agents and what are our reducing agents. So here we can see water is an oxidizing agent, and so is our chromium 2 ion. They're quite close together. And then over here, our chromium 2 ion is also a reducing agent. Water is a reducing agent, and water and our chloride ions are reducing agents. Again, our strongest oxidizing agent, we're going to pick the one that shows up first when we're going down the page. So that's going to be our water. And then to pick our strongest reducing agent, we're going to start on the bottom right-hand side and look up. Our strongest reducing agent is our chromide ion, right? That's the one that shows up first from the bottom on the right-hand side. So let's go ahead and label these and then write our half reactions. So our chromide ion is both an oxidizing agent and a reducing agent. Chloride and water are reducing agents. And then water, of course, is both an oxidizing agent and a reducing agent. Our strongest oxidizing agent then is our water, and our strongest reducing agent is our chromide ion. So here, Cr2 positive as a, I'll start with water. I've always been starting with my oxidizing agent. So water, we've got 2 H2O plus 2 electrons. This produces H2 gas and 2 hydroxide ions. And then our reducing agent is Cr2 positive becomes Cr3 positive plus 1 electron. So to add these together, we of course need to balance our electrons. So we're going to multiply this by 2. We should have 2 H2O. Our electrons now cancel out. 2 Cr2 positive. That produces H2 gas plus 2 hydroxides plus 2 Cr3 positive. So don't forget, guys, to carry that 2 all the way across. If that's something that you're struggling with, write this all out before you add it together. All right, then we're going to check for spontaneity. Here, our oxidizing agent is below our reducing agent, so this is a non-spontaneous reaction. So to answer the question then, a solution of chromium 2 chloride would be stable because we can see This is a non-spontaneous reaction. This reaction actually wouldn't happen. Perfect. Okay, so you guys have some homework to do. You guys can get started. Lots of disproportionation questions in there, writing out your entities. Practice hard. If you guys need me, don't forget that I am available. You guys can contact me and I can certainly help you out. Good luck with everything.